All right, now let's talk about completing the square. That's how we're going to solve quadratics. And you do this, when you need to add a term to an expression, x squared plus bx, to make it that perfect square trinomial. So just like what we did in the last video in problems number 3 and 4 in the notes, that's what we're going to do to complete the square. That's that b over 2 and that all being squared. All right, and down here under the core concepts, it kind of shows you, and that's where I gave you that information. Okay, that's where I got it. And that is how we can solve some quadratics. Okay, that's one of our methods. So we've done it now. We've done solving quadratics by factoring, by graphing, by square roots, and now here's completing the square. So the problem with graphing is we can't get our imaginary solutions. The problem with factoring is not everything is factorable. And then the problem with square roots, solving by square roots, well, there's no x in the equation. There's an ax squared and there's a c, but there's no bx. Okay? So for completing the square, now we have the bx. And completing the square will work for every quadratic equation, no matter what it looks like. Okay? And same thing with when we get to 3.4. That method can be used for any quadratic equation as well. So let's give it a try on number 5 and 6. So we're going to do this first. 5 and 6 is when so the coefficient of x squared is 1. All right, and then we'll do the next video, we'll have when a is not 1, and there is a coefficient in front of x squared that isn't 1. Okay, so for completing the square, the first thing I do is I move the constant to the other side. Okay, I want it so I have x squared minus my bx, or plus my bx, okay, over here, but I'm going to have plus some number. I don't know what it is yet, but it's going to equal that -7. Now, I'm also going to add whatever number I add to the left, I have to add it to the right, because you can do that. That's what we do. That's what I just did right here. I could subtract both sides by 7. I can't just subtract one side and that 7 just subtracts over there. I have to do things to both sides, and it's equal, and it works. So that's what we're going to do. We'll add a number to both sides, but we need to figure out what that number is. And that's where that b over 2 squared came from. So RB is -10. I'm going to divide it by 2, and I get -5, and I square it. So I'm going to take b, I'm going to half it, square it, add it to both sides. Okay, that's the phrase I always use. Half it, square it, add it to both sides. So if I half it, I get -5. Square it, I get that magic number, which is 25. But I have to add it to both sides because I want this side to be factorable. That was the point. So I can write this as that binomial. Remember, it's just halving the b. It's not being squared, and then I write the squared outside instead of squaring that 5. And then I still have it equal to this side, which is -7 plus 25 gives me a +18. And then I can solve this by square roots now, okay? I had to complete the square. That's what we did when we did this. So we don't call this method solving by square roots because I had to do something before I could solve it by square roots. But from this point, it's just solving by square roots. Well, I have something being squared on the left all by itself, and then I have a constant on the other side. So to get rid of the squared, I'm going to square root both sides. And when I do that, the left side just becomes x minus 5. The inside of the squared, or inside the parentheses, does not change, okay? But on the other side, when I square root the other side, I get a plus or minus square root of 18. Okay, so we keep going. And I need to add 5 to both sides because I'm solving for x. That's the whole purpose here. So I get x equals, now this 5 has to go before the plus and minus, okay? Because I'm just adding that 5 always, and it's plus. It's positive because I added it. So it needs to go in front, and then I still have the square root of 18. All right, now, this is your answer, except square root of 18 can simplify. So let's come over here and simplify our square root of 18. It's the same thing as saying square root of 9 times square root of 2. Square root of 9 is the perfect square because I can take a square root of 9 and I get 3. So I no longer have a square root with that. But then I still have the square root of 2. Okay? So my final answer is going to be x equals 5 plus or minus, and I replace that square root of 18 with 3 square root of 2. Now again, this really gives you two answers. It gives you 5 plus 3 square root of 2, and it gives you 5 minus 3 square root of 2. You can write it either way. All right, number 6, let's give it a try. Let me kind of separate my problems here. So I need to get my constant to the other side. So I have x squared minus 18x plus something I don't know is going to equal, now I had to subtract the 5 to move it, so it's minus 5 plus a number I don't know. Okay, so right now, before I put any plus on both sides, it's the same, it's the same thing there. I just moved the 5 to the other side by subtracting it. Okay? But now I need to figure out what this magic number is that I add to both sides. So you take b, you half it, square it, add it to both sides. So negative 18 being cut in half is negative 9, and I square it, I get 81. So I'm going to add 81 to both sides because it's negative 18 over 2 squared. That's where I get the 81. All right. So this left side becomes it's that perfect square trinomial, and it's going to be minus 9 because it's half of b squared equals, and then the right side is negative 5 plus 81, which becomes 76. From this point, we solve it using square roots. Square root both sides, I get x minus 9, and then square root that right side, I get plus or minus the square root of 76. All right, add 9 to both sides. Now remember, that 9 has to go in front of the plus and minus, so it's x equals 9 plus or minus the square root of 76. Let's simplify our square root of 76 over here. Whoops, not 6, a square root of 76. The biggest perfect square that goes into it is square root of 4, because I get 19, which is prime, so I know nothing goes into that. Square root of 4 is a 2. So this all stayed the same, plus 9 plus or minus, but now I have a 2 square root of 19. All right, you can leave your answer as that with the plus or minus in the middle, or write it as two answers, 9 plus 2 square root of 19, or 9 minus 2 square root of 19. Those are the same answers. All right, so go to the practice and do 25, 26, 28. Those are solving by completing the square where a is 1. And then move on to the next part where a is no longer 1.